Hello world, hello Philippines, hello other parts of the world, and now I am coming back for my lives to read regarding mass transfer or transport phenomena. So it's gonna be a combination of momentum transfer, heat transfer, and mass transfer, and somewhere along the way also in combination of physical and chemical separation processes, right? So please understand that it is really a mixture, okay? I cannot focus in one area because it could not be denied are really interrelated with each other. Okay, especially there are problems that needs to be solved in this particular momentum transfer and then also related to heat transfer somewhere along the way. It's a combination. That's why my type of live streaming for today is gonna be a zigzag type of discussion, like an erratic movement, or shall we say, in science or in chemical engineering term, it's gonna be turbulent. It's not laminar because laminar is very systematic, organized, and then it will become scripted somewhere along the way, and too much, chronological order. But here, don't expect me to discuss in chronological order in an organized fashion. For me now, it's just like abrupt and extemporaneous, meaning what comes in my brain cells that we have to discuss as long as it will connect to the specific problem that I will be able to show and to be able to elucidate in front of you, or that I will be able to present to you guys. Okay? Read it out. 3, 2, 1. Okay. So the first thing to do is to analyze the problem. You go directly how we don't have to talk a la chuba chuba choo choo. We go directly to the problem, okay? So the first thing to do is you have to feel and analyze the problems, the applicability and suitability of what topics are gonna be involved for that particular problem solving. It's not just, oh my gosh, you didn't have to, you didn't have to word for word. No, it's not like that. You have to analyze, okay? You don't have to be literal, but you need to be conversant in terminologies, or you need to be adroit in understanding the terminologies involved in that particular problem solving, because not all the times they will be able to input common terms and words or statements somewhere along the way in the problem solving also. But anyhow, that could be manageable. Okay, so it's up to you guys. So what I'm telling to you that you should also be a wide reader. Okay, something like that, and resourceful, and try to have your own initiative. Okay, despite of your busy schedules nowadays, because you need to enjoy with your barcadas. You have to go out, and you go to the beach to unwind, but you have also to prepare yourself, especially if you are taking future examinations, something like that. Especially prelims, midterms, and finals, something like that. But it would be okay because today is, most of the studies are through modules. It's very easy to manage, and you can maximize your potential to solve very well if there are problem solving also, especially for the theories, okay? Because you are not in the classroom. To be alone in your room and study a lot in online internet surveys regarding academic information, whatever. So, you can explore everything, maximize. But if you are in the face-to-face, oh my gosh, it's limited. There are your classmates will be there. You will be tempted in going to them to take your snacks, something like that. Okay, go to the city or whatever, window shopping, whatever. Okay, go to the cinema and watch movies. Okay, but if you are alone in your room, you can maximize your time. You can focus to academic information. Okay, especially if you are facing examinations, prelims, midterms, finals, and especially engineering licensure examination. Okay, guys. Or any, for example, if you are achiever and you are really one of the top contender academically in science in your school, then you will be able to join science quiz bowl, science fair, something like that. For example, if you're a champion of chemistry quiz bowl, you're a champion of physics quiz bowl in your particular school, then you'll be able to represent your school, in another, places, then you have to be focused. Then you certainly have to focus, okay? Focus your study very well. There's a lot of things, right? It's not only through examination, for employer examination, because sometimes it could not be denied also in employer, employer examinations have also science examinations somewhere along the way, or mathematics, okay? Have also vocabulary and psychology tests, okay, somewhere along the way, but there's also a little bit of science, a little bit of mathematics, okay, in employer examination, okay, right? In hiring process, especially for those companies that are very reputable or prominent company all over the world, very class A company. So the recruiting process and system is very strict and meticulous. Okay, so very rigid like that. It's not through backup or connections. It's really through your intelligence, your efforts, how you answer effectively on the interviews, something like that, on a panel of interviews during the preliminary interview, second interview, and then examination. Okay, later, written, verbal, something like that. Okay, because I met also type of interviews like that a lot before, especially Saudi Aramco. Okay, Saudi Aramco is very stringent. Okay, so there are a lot of panel interviewers in front of you. Okay, something like that. But then they will pick up only 2 out of 10, out of 5, something like that. Okay, but that was before. Okay, but now it's another story because, oh my gosh, I'm already aging. It cannot be denied that through aging biologically, we are not very quick in some academic information or whatever knowledge that we have right now. So it's not really that, fast compared to our younger days. Okay, because as I told you over and over again, okay, our collagen drop when we are aging. Okay, so protein contributes to the nutrients that will go to our brain cells. So it will activate to our brain cells like that, and whatever crucial organ that play an important role in memory retention, okay, especially in IQ, intelligence quotient. So we need nutrients also. But then, through collagen drop, one type of protein, so we cannot have a strong or higher retention of memories. Something when we reach 40 plus, 50 plus, 60 plus, our knowledge is not the same when we are young. Because when we are young, our brains are very active because we are very young, of course. Okay? Something like that. So it's gonna be the biological process and we cannot deny that. Okay? It has been studied already that when we grow old, our memory will become less. Okay? Compare when we are young. Okay? And also physically, we cannot move very well as compared as before. We are not as energetic as before also. Physically and mentally. But if you're trying your best to do a lot of research, reading, and then you spend most of your time doing research, reading, and then all about, academic information, whatever, then you can add your knowledge, and then you will not be stagnant. You are keep on moving even though despite of your age. Okay? That's very clear. And I was very talkative. And that's what out of the topic. Now we'll go back to the problem. Oh guys, read. Okay, this is the problem. Guys, I remember this problem when I was, this is 3rd year. Oh my gosh. Wait. Diffusion. Okay. 4th year. Okay, unit operations. It's gonna be, mass transfer. This is mass transfer really. Okay, so question number 2. Oh my gosh. Ganon. So take a time to read for at least 2 to 5 minutes and then extract the data and troubleshoot what are the required and then what comes in your mind, formulas, equations that best correlates to this particular problem. Okay, guys? Oh, it's gonna be like that, huh? Okay. Take a look. So take a look at me now. There's just an empty space. O, ganon. Diba? Okay, now, Oxygen gas is flowing through a 10-meter long circular pipe with a radius of 16 centimeters. The concentration of oxygen at the ends of the pipes are 30 kilogram per cubic meter and 10 kilogram per cubic meter. The diffusion constant of oxygen at 20 degrees Celsius is 1.10 raised to the power negative 5 meters squared per second. Now, these are being required or being asked in the problem. A, calculate the diffusion rate. B, how many kilograms of oxygen will flow through this pipe in 15 minutes? C, calculate the concentration gradient. Oh my gosh, there's a lot of questions. How can you do this? So lengthy. Okay, letter D, what is the concentration of oxygen? 2 meters away from the end of the pipe at a high concentration. E, how long will it take 100 grams of oxygen to travel through the pipe? Diba? So, analyze that one by one. Okay, so let's have a symbol or variable in doing that. Okay, so let's do the first step in problem solving systematically. Okay, as usual and as consistently as I am ever since in discussing in front of you guys. So I have to say this, we start with elucidating the data or presenting the data and given. Okay, how can we do this? Oh my gosh. Okay. Andiyan na naman si June. Yes. Okay, data. First step is to enumerate and to list the data, okay? Data are given as just the same. So oxygen gas, oh my God! Oxygen is the most abundant element in the planet Earth. Okay, it is highly reactive and it will always involve in combustion process in hydrocarbon or in petroleum industry, okay, or in producing fuel gases, diesel fuel, and okay, to have gasoline, something like that, kerosene, or whatever that speed ups our mobile cars or whatever, right? So this is very useful actually. Not only that, oxygen is a precursor to the most biological substances inside our body. Okay, biosynthesis between chemicals and biological substances through synthesis. Synthesis meaning different kinds of reactions involved. Okay, the chemistry inside our body, the chemistry inside our digestive system, okay, or any parts of our immune system, okay, because biological and chemical substances are always present, okay. So oxygen is always very, very important, guys. Oh my gosh, that's why we have polarity. We have a stored electrical energy. We human beings have a stored electricity or electrical energy due to the polarity of this oxygen, because we need to drink water every day, and oxygen is having -2 charge, okay, and it's very highly polar, okay, so that's why we have current inside our system, okay, and water is highly conductive to electricity, okay. So usually you will be electrocuted if there's a presence of water around you and there's a presence of electrical energy, especially if there is an exposed, damaged outer layer of the electrical cable, whatever, and damage of physical condition of your tools that involves electrical accessories or connectors or whatever. Okay, so going back. Okay, given and data. Oh my gosh, circular pipe. Oh, long circular pipe. So how can you interpret this? Long circular pipe. Okay, actually the noun is pipe. The adjective is long circular. Okay, long meaning lengthy. It talks about the length. And circular, it talks about the geometrical shape of a pipe. So we can say in this manner that we're going to use the cross-sectional area, which is pi r squared, if we try to compute for the cross-sectional area of this long circular pipe. Okay, guys? Okay. So radius is 60 centimeter. Oh my gosh. Radius. Small letter R is our radius. Oh my gosh. Long battery. I have to charge this because I need to vlog with microphone because you know the modulation of my voice is very clear and with intensity. Okay, I'll just charge this one, guys. Okay, and then producing a quality sound. Charot. With echo. Oh my god. Diba? Echo. Oh my gosh. Diba, guys? Ganun. Oh my gosh. Oh my gosh. How can I do this without microphone? I just make my voice clear and louder enough in order I'll be heard. Anybody can hear me now? Speaking in front of you. It's okay to have this kind of voice. Oh, like this, okay? Well-modulated voice. Very difficult with the microphone because the purpose of the microphone is to intensify the intensity of your voice. Okay? Something like that. So that's the purpose. And the echo also will help a lot in order to convey the message very well. Okay? Convey. Gosh. So 60 centimeter radius. Okay. The concentration of oxygen at the ends of the pipes are 30 kilogram per cubic meter and 10 kilogram per cubic meter. Sorry for that. Okay, so I have the pipe here. Okay. Hoy, sorry, somebody said to me I'm Englishero. Sorry. Okay, I'm comfortable speaking in English. Though I love being a Filipino and I'm very, very proud being a Cebuano, but you know, I love to talk in English. Sorry for that. Okay, in the benefit of other viewers all over the world. So that they can really also understand what I am talking to, especially in the topic of science and chemistry, chemical engineering subjects also, okay? Because this is applicable all over the world. Something like that. Okay, guys? Sorry for that. Somebody said, oh, Englishero. Oh my gosh. Kaloka. Okay? So, never mind. Okay. Okay, so the length is 16 centimeter. Okay, it's long circular pipe ha. So through a 10 meter shaft. Okay, but don't you worry, I will combine it with Bisaya or Tagalog sometimes. So Bislish and Taglish. Okay, something like, diba? Bislish. First time you hear that one, right? I created my own term, Bislish. Okay, so I want to be unique. Okay, I want to create words that I don't want to copy. I don't want to be a copycat. Okay, I want to establish originality. Okay, in everything that I have to. Something like that. Oh my gosh. Sorry, somebody will say I'm arrogant. No, it's not. This is really my natural. Really, I didn't force to be like this. Okay. Really, it just come out since I was very young and until now. Okay, I was blessed with this kind of ability. Oh my gosh. So, the length is 10 meter. And now we have the radius, 16 centimeter. Radius, guys, is the half of the diameter, right? So, it means small letter t, which is equal to the diameter, is equal to twice of the radius. So, d is equal to 2r. Right? Okay. So this is 16 centimeters of radius. Oh my gosh. Radius 16 centimeters. In this situation, we need to remember also the circumference, which is 2 pi r, and we need to troubleshoot the value of the pi without using the scientific calculator. That is 3.1416. I memorized that since elementary level. Okay? That's why it keeps stagnant, or it's retained in my brain cells up to now. Okay, so if you start memorizing when you are in the very young, then it will retain in your brain cells. Okay, especially when you read every day like that, and you know what I mean, right? Sa makarelate lang, you know what I mean. Okay, so 16 centimeter. Okay, now, oh guys, so tricky. You know tricky, T-R-I-C-K-Y. So confusing. Okay, something like that. Tricky is an adjective that leads the audience, the examiners, or any individual to be confused. Because there's a gray area somewhere along the way that you cannot comprehend properly. Gray meaning G-R-E-Y. not the gray color. That is really a homonym. Okay, homonym is the same rhyme, something like that, the same sound, but different in meaning. Okay, or specifically to be specific, the same spelling. Okay, but it has different meaning. Okay, something like that. You get the point? Oh my gosh, like that. Okay, so oh my gosh, 30 kilogram cubic meter. So let's say at the ends of the pipes. Okay, the ends of the pipes is here. I draw and illustrate. This is the second step, right? Illustrate na ko. Okay. First step is to, present the data in the given, and then second, illustrate so that we can understand what are the suitable and applicability of the formulas and equations to be used. And then since you know already what are being required or what are being asked in the problem, something like that. Okay, so this is 30 kilogram per cubic meter. Okay, gosh. Guys, don't feel boring now when you always hear these units all over and over again. Okay, so kilogram per cubic meter is the unit of density. Okay, so 10 kilogram cubic meter. Okay, so at the start of the inlet of the pipe, there is a 30 kilogram per cubic meter, and the outlet is 10 kilogram cubic per meter. Guys, you need to undergo the relationship with the velocity. Okay, the velocity and the area. Okay, when the area is very small, the velocity is very fast. Okay, if the area is very big, okay, and then the velocity is very low. Okay, now it relates to pressure also. When the velocity is very high, the pressure is less. When the velocity is less, the pressure is too high. So you're gonna troubleshoot the relationship. Okay, if you are taking engineering, you must understand the relationship, the direct proportionality, and the inverse proportionality first, the theory and concept, before going to problem solving. Okay, you maximize first what it's all about. Okay, so that you can really understand. Because the problem solving is an application after you extract the basic concepts, theoretical aspects, and learning throughout that specific topic. Okay, so application na lang yun na siya. Okay, but first it should be starting with a principle, foundation, theory, concept. Okay, so whatever, it could be rambled or mixed in the future, whatever, so you can really solve the basic formulas and equations, something like that. What are being asked? Kaloka. Diba? Ganun siya, guys. O, tanawa kong drawing. Diba? O, okay. The diffusion constant of oxygen at 50 degrees Celsius is 1.8 times 10 to the negative 5 square meter per second. Diffusion constant. Oh my gosh. Diffusion constant is the same as diffusion coefficient. Ha! Okay. Diffusion. I will denote that as TO because oxygen is the one who will go to the pipe. Okay, and then the first letter of oxygen is capital O. Then my subscript will be O. So TO. Okay, so diffusion coefficient of oxygen is equal to 1.8 times 10 to the negative 5 raised to square meter per second. Okay. Oh, this one. So guys, note that the diffusion coefficient or diffusion constant, it should have area at the numerator and a time in the denominator. So therefore, we conclude that the formula of diffusion coefficient or diffusion constant will be equal to the area over time. Okay? Even though our instructors did not teach that, then through that unit alone, we can create our formula by our own comprehension. Okay? By its unit alone, investigation of the units. Okay? So we have now, so complete na itong mga formulas, mga given. Okay. Calculate the diffusion rate. Andiyan na naman tayo. Rate. If I talk about rate, especially interest rate, okay, compounded interest rate, annual interest rate, what comes in our mind is the time interval and period. It's gonna be seconds, it's gonna be minutes, it's gonna be hour, it's gonna be day, it's gonna be a month, it's gonna be a year, it's gonna be a decade, and it's gonna be a century. Right? So that is rate. So the time will be in the denominator when we speak about diffusion rate. So diffusion, so it's gonna be mass flux over the time, like that. Okay, so and dMA d over dt. Okay, something like that. So diffusion rate. Okay. So maro kay ang kuan mass transfer because the symbol is very unique compared to others. It's capital J as in char. So J, what's that? G, oh my gosh, G-A-Z. Kaloka. Okay, so G-A-Z siya. Okay. So, G-A-Z, by the way, we need to solve this in algebraic approach. Okay, I don't want to solve in a calculus approach because, it confused me a little bit. Oh, a little bit. Really, when I established the limits, oh my gosh, how can I do this? But if you solve in algebra way, okay, it's very easy. No, it's not very easy. It's very simple to understand. Okay, not complex or not complicated. If you use the calculus, oh my gosh, it's lengthy and at the same time it will confuse you a little bit. How about trying the basic math, which is only an algebra? Okay, so I use algebra approach here, which is very common and applicable to all types of problem solving with regards to science and mathematics. Okay, because when you talk about calculus, that would be applicable most of the times to engineering students. Okay, but for the basic math, it will be applicable to all. Okay, whether you are not an engineering, College of Arts and Sciences, Business and Administration, BA Psychology, mass communication, like that. Okay, they can also relate because they have minor mathematics in their minor subjects also. Okay, so it could not be denied mathematics are being studied in all curriculum. Okay, whatever course. Okay, let's do the algebra, not the calculus. Later we will be dealing that, but don't expect me to do that, but hopefully, okay? Something like that. So, diffusion rates, ganun siya. So, GAZ, okay, GAZ is equals to the diffusion coefficient of oxygen times the area. Uy, chararat. Diba? Area, and then times the concentration gradient. Okay? Concentration 2 minus, concentration 1. I will tell you, concentration 1 minus concentration 2. Guys, most books represent C2 minus C1, the concentration gradient, but they put negative in the diffusion coefficient. But there are two ways to do that. If you don't want a negative sign in your diffusion coefficient, you will say C1 initial minus C2 to avoid the negative. But if you don't want to avoid the negative of the diffusion coefficient, then use the C2 minus C1, which is the regular one. But in me, I don't want to have negative. So I want to delete that negative, then I will reverse this concentration gradient as C1 initial minus C2 final. It depends, just like in electrochemistry, okay, in Nernst-Simons equation, okay, in electrochemistry, so you have to reverse so that you can remove the negative sign, something like that. During the derivation, it will come out in your derivation y. And just like also in the Arrhenius equation of chemical reaction kinetics and the Eyring and Pugliese equation of transition state theory, something like that. So you have to analyze, oh my gosh, I need to avoid this negative sign. Then you have to reverse on the other side. Okay, something like that. Okay, I don't have to elucidate that here. I don't want to present that here because that's not our main concern. So let's go back. Okay, but I want you to tell you only a little hint. Okay. So, like this, over L. Ganon siya, guys. L. The L, if we relate this to a movie, This L is the actor. Actor, because this always be present in all the transport phenomena quantities, whether in heat transfer, mass transfer, momentum transfer. The L will always be in the denominator because the L represents the x-axis, or shall we say the length in horizontal axis, or it could be the thickness in horizontal axis, something like that. So which is which, you can feel that in the problem also. Okay, you get the point? And L sometimes denoted as X, sometimes denoted as Z. If you are really a resourceful student, you can really troubleshoot how the books are being discussed, the contents there, in different authors. Some authors use different variables, and it will confuse sometimes the students. Okay, that's why you need to be clever and smart enough to detect, oh my gosh, what's happening here? My teacher put Z, but why here is X? So it's just only a representation. It has the same meaning, only the representation of the nomenclature, symbol, something like that, that the author of the books or that particular topic are being presented. Oh my gosh. Ganon. Okay? So let's substitute values na siya. Okay. So diffusion coefficient is 1.8 times 10 to the negative 5. Di ara. Substitute. Ganon. So what is equals to 1.8 times 10 to the negative 5 square meter per second. Area! Hala! Could I use the cross-sectional area or the surface area? There are two types, right? So do not be confused. Surface area applicable only in the rectangular shape, or it could be a square, or it could be a rhombus, a trapezoid. Okay, something like that, but it cannot be applied in the pipe, which is a circular opening. Okay, so just like a vessel or a tank, so it's different. It should be the cross-sectional area. So we will use the pi r squared. Okay, so pi r squared. So sa ganitong pi, 3.1416. Okay, 3.1416. Okay. Pi r squared. Our radius is given here, oh my gosh, 16 centimeter. Guys, 16 centimeter is not compatible with the other units there because the units are expressed in meter. You need to convert this immediately or automatically. Okay, so that it will not be confused somewhere along the way. So convert 16 centimeter to meter. It's gonna be 0.16. Okay, by using only the brain cells. Because, 100 centimeter is equals to 1 meter. Okay, then if dealing with 0, it's very easy to troubleshoot, right? Okay, I think it's gonna be 0.16. Okay, but let's just try the calculator to make it safe. Okay, so 16 divided by 100. Okay. 0.16. Okay. If you're taking also engineering, you need to develop the short technique, and you should also develop that at an early stage of your education when you are still in the first year level of engineering studies. Okay. So 0.16. Okay. You should be independent. That's what I am telling you. Independent. Okay. You should not be dependent from your instructors. Okay, they will only guide you and you will receive and they will transmit their knowledge to you, but it is not an assurance that they will deliver everything what they learned. Okay, so you need to be resourceful and you have to have initiative. Okay, so you should be independent. Okay, so we have 16 centimeters and 0.16 meter. Okay, so if you have that quality, so most of the times you will pass future examination. Okay, so 0.16 meter raised to the power 2. Okay, times. I genuinely blame my instructors. Don't blame the instructors and your mentors because that's their way of their style in teaching. Okay, so maybe it would help in that manner, so that in order for you to strive hard. Okay, so there's a purpose behind that. Okay, so you cannot force them to feed you the way as I did, for example. Okay, because I'm just like spoon feeding you guys. Okay, but if you are in the college education, you will never experience like this, that this is gonna be like this, the terminologies, I'm very articulate with the terminologies, okay? Because I love to become a broadcast journalist in the first place, okay? I don't have a dream to become a chemical engineer when I was very young after my high school. Okay, I keep this telling to you guys over and over again. Okay, since there's no broadcast journalist or mass communication in my academic scholarship, then I choose the most nearest course, which is BS Chemical Engineering, because I love science and I love chemistry also. It just happens, okay? But it wasn't intentionally done. Okay, guys? So, gonna be like that. The way, I'm talking, right? So if I am an engineer, I will go directly to the point and less talks, right? Because most engineers cannot talk properly. Okay, let's admit this. Okay, majority of the engineers cannot talk properly. They are very, very straightforward, but they have high ability in mathematical aspects. Okay, strong critical thinking and reasoning by numbers and figures and logical thinking, but they are less words. But me, it's the reverse, right? Okay, so it's just, it just happens. Okay, so concentration. Initial concentration minus the final concentration. Okay, we have initial concentration here is, oh my guys, oh my gulay. Okay, I will teach you also. This is it. Oh my gosh. Dapat sana discover na ako when I was in college. Okay. This one. 0.1, 30 kilogram per cubic meter. At the outlet is 10 kilogram cubic per meter. I keep on thinking, going back to my younger years, but admittedly, I'm telling the truth. When I'm taking the board examination, I want to become a top-notcher. Really. That's my aim, very high. Okay? Now, when I go back to my school today, oh my gosh, maybe my scores will be higher. Because just now I learned some. Really. Just like this. Okay? I'll teach you, Okay, I know already the basic concepts, but there's a little bit of, strategy. Because most of the students, including me, we are just dependent. If, for example, concentration, the unit must be that one. And we don't consider the condition, how this fluid and liquid move in that particular pipe, vessels, tanks, whatever, it matters there, the molecular weight, the density, and your basis of calculation will matters a lot also, something like that. So you will never be dependent, concentration, the unit is like this. The unit of this is not concentration, imagine this is density. Okay, so in this problem, you will be confused because mass transfer diffusion involves concentration gradient in the first place. Take note. You will interpret this as a momentum transfer. Why? Concentration gradient is not mentioned here. The unit is not moles per liter. Either it's not the molality, okay, moles per kilogram, or it's not the normality, equivalent weight of solute per liter of solution. It's not really solubility unit. But why this kilogram per cubic meter will become a concentration? And that's the question to be answered now. Okay? Okay. Because we need that here to subtract the initial concentration to concentration 2. But we don't have concentration, that's density. Density is not concentration in the first place. Okay? Is that the point? Now, this is the time theory will correlate or will connect. Theory and basic concept. Now, take note, what will go to the pipe? Solid, liquid, or gas? It's oxygen. Okay, our atmosphere God created, okay, oxygen is 21% without consideration of the pollutants and contaminants. Okay, the ideal concentration of oxygen, and 79% of nitrogen by volume, free, God gave to us. That's why 79% times 21% equal to 100%, and I thank you. And this nitrogen is not reactive. So when we say not reactive, that is noble gas, meaning it is really a stable by itself. Oh my gosh, I don't want to react with anybody else. I am stable. That is inert or noble gas, highly reactive at its original state without any chemical reactions to any other nonmetals and metals. Okay, that's very clear. That's noble and inert gas and reactive. That's why nitrogen, argon used as an purging in a confined space because it will never react to other harmful and toxic gases inside a confined space. Okay? So that's the reason behind. Okay? Because if it will eat oxygen content inside or consume the oxygen content inside the confined space, then the people cannot breathe. There is no air anymore. Okay? That's why before going to the confined space, they must purge, P-U-R-G-E, with argon gas. Because argon also is an inert and noble gas, highly unreactive. Okay? Very clear, right? Okay, going back. So, this is densities. These are densities, wrong grammar. Pati grammar. So, 30 kilogram per cubic meter and 10 kilogram per cubic meter. Okay, now, what? Oxygen, once again, is a gas. The most abundant element or gas in the planet Earth discovered by Jules Priestley. Okay, got the point? And this is very an oxidant also in producing nutrients or any synthesis in our body. I don't have to explain further, it's biochemistry already. Okay, so what we do with this oxygen, so that we can come up with a concentration in terms of moles per liter, which is the standard unit of molarity, concentration, and solubility. Solubility, molar, represents capital M. When you go to your laboratory, so the chemist will prepare a solution and you will see the capital M declared in the bottle, in the transparent bottle, flask, or whatever, or beaker. That means molarity, moles per liter, capital M. Or they will express it as a molar, M-O-L-A-R, that is moles per liter. Okay, now this outlet and inlet, this is not yet a concentration, this is density. How can we relate this to concentration? Now we do derivation and correlation. Oh my gosh. Okay, now this, remember the formula of density and concentration. Nakakaloka? Diba? Guys, are you still there? Hello? Hoy, BBM supporters, are you still there? My gosh. Do you hear me? Wow. Okay. Guys, we need to connect this to ideal gas law. Because in mass transfer, especially involving gases, very diffusive fluid and liquid. Okay, diffusive meaning the density is very light. That's why it always diffuses easily compared to liquid and solid. Okay, so if it is having a lower density, the more it will diffuse faster compared to solids and liquids. Okay? Okay. What is an ideal gas law? That is also a general equation. Okay? So I will show to you the equation for this. You should remember also the Clausius-Clapeyron equation. Okay, you remember that one in thermodynamics, second law of thermodynamics or first law? It's going to be second law, right? Okay, and to establish the thermodynamic properties. Okay, you can easily understand. Okay, you get the point? Nakakaloka. Okay, katulad ng mga work is equal to pressure times volume. And then since the work is pressure times volume, then substitute that there. Now it will become a PV and RT. So actually, the ideal gas law formula is not really a standalone equation. It's not an original equation. It came from work is equals to pressure times the change in volume. Since we know that work is equals to PV, then substitute that there. then it will become PV and RT. So it came from second law of thermodynamics really. Okay? Correct me if I'm wrong, ha? Tao lang po. Okay, so it's gonna be like that. So, PV and RT. This is the most widely used equation in gases, especially if the gas is ideal, with the compressibility factor Z, which is to 1. Compressibility factor Z is equals to pressure times molar volume over the molecular weight. Okay, something like that. You remember that one? PV in molecular weight times temperature. Okay, compressibility factor of a gas. So that you can troubleshoot if it is an ideal gas or a non-ideal gas. Okay, di lang kayo, sige lang kag-solve. Wala na siya mutuman. Dili na siya ideal gas, sige lang kag-ideal gas. That is non-ideal. So use Van der Waals equation of real gases, right? You get the point? So PV is equals to nRT. Okay, guys? PV and RT, the most common and widely used equation all over the world in chemistry or in physical chemistry, thermodynamics, and of course also unit operations. Okay, something like that. In chemistry, in fact, right? The origin of chemistry really, and physics. These are the pure sciences. Okay? So, PV is equals to RT. So since we know that this is a density, then we correlate the density to the ideal gas law equation. So density is equals to mass over volume, right? Okay. We need to troubleshoot here. Density is equals to mass over volume. And since we know the volume is present in the equation density, then there is also volume here. Then substitute in terms of volume. Then do the basic math. Okay, for volume. Okay, so how can we do that? I will just illustrate, very easy. Density is equals to mass over volume. So volume is equals to mass over density. Substitute that here. So pressure is equals to mass over density. Okay, guys. Ganun siya, chuba-chucho. Is equals to nRT. Therefore, we conclude that PM is equal to density nRT. Okay, guys? And then pressure is equals to density nRT over N. This is our equation 1. Okay. We have now an equation 1 in terms of density. Because the problem have a given of density. Okay, now guys, if we have the density, we should also have to compute for the concentration because mass transfer focus on the concentration gradient as our driving force. Did you magpaalakan si concentration? Right? Why did you ko mapapili ni density? Because this is me. I am the driving force of this mass transfer. Right? It's gonna be like that if you try to relate that to a person. Okay? So concentration. Moles per liter, so it's gonna be capital N over V, right? Capital N, guys, that would mean number of moles. So sometimes you will be confused because in chemistry general chemistry lecture, we are taught that the small letter N is the number of moles, but in here, the capital N is the number of moles. Okay? Not the small letter N. Okay? But you should only need to understand so that there's no problem at all. Okay, so it's gonna be like this, guys, So concentration, wow. Concentration is equal to moles per liter. Moles per liter is equals to, okay, N over N. So concentration N over liter. So this N, we have this also in our PV and RT, in which it represented as the small letter N, right? So substitute that here. So we're going to substitute that here. So it's gonna be N is equals to C times L, concentration times the volume. So concentration times the volume, substitute that in the general equation, ideal gas law equation, then compute, okay, for the value of pressure or anywhere else here. Okay, so substitute. So we have now number of moles, capital N is equal to the concentration times the volume. Okay, liter man ang volume. Okay, capital L is the liter, so that's volume na siya talaga. Okay, so CV. Okay, this is not a curriculum vitae, the transcript of records or whatever. This is concentration times volume. This is not a resume. This is concentration times volume, CV. Okay, like that. So substitute that here. It's gonna be like PV times CV RT. Okay, what do you will notice here? There's the same terms, capital V cancels the out because it's in the upper portion. Okay, cancels that out. Left and right will be cancels out. So cancels the V, what we mean is pressure is equals to, okay, CRT. Ganon. So equation 1 and equation 2, guys, notice. Equation 1 and equation 2, notice there are parallelism. Parallelism meaning similar quantities pa siya. Now, that will not matter somewhere along the way when oxygen moves through the pipe. Okay? The specific gas constant, capital R, of course, and the capital T, which is in terms of Kelvin, are considered to be negligible and constant somewhere along the way when we deal this mass transfer. Because this is not heat transfer. Our driving force is not temperature in mass transfer, it's concentration. So temperature is not an issue here. We treat that usually as constant and negligible and irrelevant somewhere along the way. That would be only our basis so that we could have a basis for our pressure. Okay? Because of course, all gases, substances that will go in medium or whatever it is, that has always density, concentration, or whatever, right? So it's gonna be like that. So temperature and R is not an issue. But since you know, 1 and 2, nagcompute sa pressure, so what will come in our mind? Again, algebra, basic math. Okay, we will do the interpolation or the ratio and proportion. Okay, 2 techniques and strategies in mathematics to solve for other quantities is to do the interpolation and the ratio, R and P, ratio and proportion. So it's gonna be ratio and proportion only with having the same similar quantities because we are dealing with ideal gas law here and the same quantities are involved here. It's gonna be the pressure, the specific gas constant, and the temperature, capital T. Okay, now, since in this type of problem, time is not yet involved in this particular problem. So what's this all about? No need to compute for the Reynolds number because this is not a momentum transfer. Then if you want, then you can because there's a temperature. What I'm telling you, you really can, but it is not being asked on the problem. Okay, because if there's temperature, normally you can get the viscosity of the fluid or the liquid, and there's a length also on thickness and then velocity, blah, 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 bingo. Diba? So you are not concerned with that. So we need to equate this in terms of pressure, right? So it's gonna be, you will be able to substitute the value of pressure in equation 1 to the second equation. It is gonna be the other way around. The value of pressure in the second equation to the equation 1, or it's gonna be pressure 1 is equals to pressure 2 at steady state, okay, at steady state diffusion, Ficks law of diffusion. Mr. Ficks discovered this one, okay, a scientist long time ago, okay. So he discovered this Ficks, so it became a Ficks law of diffusion, treating that there is a steady state constant. So we can really equate pressure 1 to pressure 2. But if you don't want, because you are not satisfied, why? Then you have to substitute the values from the pressure 1 to pressure 2. That will be okay also. It depends on what you like, your convenience, and your comfort. It will yield the same answer. Okay, going back. So me, I love equating, charot, because chemical engineers are known to have, you know, the law of conservation of matter, the law of conservation of energy, the law of conservation of mass, and we are very, very knowledgeable to that. Okay, not all, but majority. Okay, and also the BS Chemistry graduates. Okay, so like that. So we are born to chemistry. Oh, the law of conservation of mass, the law of conservation of matter, the law of conservation of energy. That's why we need to balance the chemical reaction because of the purpose, or else we defeat our purpose while we balance the chemical reaction. Okay, that's why we have chemical calculations and stoichiometry subjects. Due to that, the law of conservation of energy, the law of conservation of mass, the law of conservation of matter. Okay. Now going back here, so point 1 will be equal to point 2. So it's gonna be like this. Mag-equate-equate. Ano kanina ni-equate ha? Because we don't have concentration in the problem. And our driving force in mass transfer diffusion is concentration. We want to defeat our purpose, okay, by just having only density. And concentrations, oh, palupig ako ni density, I am the powerful and I am the actor of this topic. Or something like that. So, di dyan mapapili si concentration. Mga sinita po. Okay. So, equation 1, ganon. Equation 1 is equals to density, chararat, density, number of moles, specific gas constant. Guys, specific gas constant, universal gas constant, or gas constant is just the same. Okay? Do not be confused with the terminologies. Okay, that would be helpful because sometimes theory will ask you like that, which of the following is a universal gas constant? Okay? A, B, C. Tagaan ka dito units. Okay? So, oh my gosh, how can I do that? So, ganon. Okay? So, density in RT over N is equal to CRT. Ay, nakakaloka. I love this. Diba? I-equate na to. Daghan ka siya ba-cancel, guys. I love it. Okay? So, density in RT over M is equal to CRT. Oh my gosh! Left and right, the RT will be cancelled. As I told you, specific gas constant and the temperature are considered irrelevant and negligible in diffusion. Mass transfer topic, right? We need to cancel this out, okay? So cancels, RT, and what will remain is concentration over the mass density times the number of moles. Oh my gosh, nakaloka. Okay? Muna siya yung hitabo. So number of moles over the mass. Hala. Eight farther. Concentration is equal to density, okay, times the number of moles over the mass. What do you notice in this? So I will give you a clue. This is the most important of all substances. Without this, we cannot compute really in chemical calculations. We cannot compute the amount of our products coming from our inlet to convert the raw materials to useful products that will be released in different industries and processes all over the world. So before we export, before we sell our products, there must be an amount produced, and we need to calculate that through overall material balance, component balance, and energy balance. So it's in there, it's very important. What's this? N over N. Hala. What's this N over N? Okay, so we need to put unit na. Okay, para mahibalaan nato siya. Okay, density is kilogram per cubic meter. N is the number of moles. Okay. And M is the grams per mole. Okay, grams per moles, guys. Okay? Like that. Take note, grams per mole is the unit of molecular weight or molar mass. Okay? And M is just simply the mass. So this is gonna be kilogram, cubic meter, moles per grams. Hala. Diba? Dito mo focus, guys, ha? Don't focus on the other side because there's a complexity. I don't want to teach you with complexity. Here only. Focus here. Okay? Kilogram per cubic meter times moles per grams. Guys, grams and kilogram is not compatible with each other. Okay? So we need to convert kilograms to grams. Because the unit of molecular weight is grams per mole. We need to parallel with the same unit talaga siya. Okay? So how can we do this? So 1,000 grams is equal to 1 kilogram. Okay, something like that. Okay, so concentration equals to 1 kilogram cubic meter. Okay, 1 kilogram, 1,000 grams, cancel. Okay, times, okay, moles. Okay, like that. Tanawa guys ha? So 1 kilogram. So 1 kilogram in the denominator, 1,000 grams. Okay, and then times pa siya sa number of moles. So our units left here will be equal to moles per cubic meter. Moles per cubic meter. What's this unit all about? This is now the concentration. Because moles and cubic meter is liter, which is concentration is equal to the moles over per volume or per liter. 1 liter is just equal to 1,000 cc. Okay? As long as the denominator is volume, this is now the concentration. So na-solve na itong problema. We have now concentration. By just having the equation to follow the steady state equation. Okay? The time is not relevant. We'll just equate from point 1 to point 2 having ratio and proportion. So since we have now the C here, so the density here now is automatically the C. You get the point? Because we already, correlate and derive in terms of the ideal gas law. So our C, even though the unit is kilogram per cubic meter, this is now also the concentration. Okay? You got the point? So things like this is really tricky, ha? And this usually be, by the way, this is Chemical Engineering Board Examination, 1988. Okay? That's why it looks like, oh, no direct. My gosh. So, something like that. Okay? Dugay na kayo siya 1988, right? How many years from 2021 minus? Okay, year 2020, 21. Okay, 2021 minus 1988. So this was 33 years ago, this kind of examination. Okay, so we have now moles per cubic meter, guys, which is the unit of the concentration. Now going back to our formula that we are trying to substitute values. So C1, guys, will be automatically 30. So, ay nagkagool, we should use 30. Bisag density ang unit. Okay, so 30 minus 10. Guys, what is our length for this? Of course, the length of the pipe, which is 10 meters. Okay, then solve by mathematical information, and we can compute the diffusion rate. Guys, the diffusion rate, guys, is just the same with the mass flux, ha? Ay, just kahadlo kay ma-origin na siya. Okay, mass flux is the diffusion rate. The only the terminologies are being revised, but actually it's very far, right? If you try to, oh my gosh, it's very far the diffusion rate to the mass flux. Okay, so sometimes you have to be smart enough that, oh, flux is gonna be a rate. Oh, ganon. So that we can, and then the diffusion coefficient is there, the diffusion rate. Okay? So heat transfer, ikuha naman siya thermal conductivity. O, ganon siya ang viscosity sa momentum transfer, sa fluid flow, or fluid dynamics, or fluid mechanics. Okay? But here, it's gonna be concentration gradient. Okay? So we need to perform the mathematical operation. Okay, guys? So how can we do this? Okay, 30 minus 10 is supposed to be sure that all units will be consistent. Okay, so that there will be no lubog somewhere along the way. Okay, so 30 minus 10 is equals to 20. 20 times, okay, ganito sa ipas lang, 20, ganon, kaloka, 20 daw, 20, okay, 3.1416 times, charot, 0.16 times 0.16, chararat, okay, gosh, times, okay, scientific calculator ha, times 0.16 because it involves exponential. So it's very difficult to deal with exponent. Okay, times 3.1416 is equals to, it's gonna be 0, 0, 0, 80, 42. Multiply the 20, multiply times 1.8 raised to the power negative 5 equal to divided by 10. So our mass flux is, or diffusion rate is 2.89 raised to the power negative 6. So this is our diffusion rate in terms of square meter per second, right? Or you can just simply cancel the units. I will show you how to cancel. Okay, but this is already the answer, huh? Okay, so this is, I will show you the units. So n squared s, okay, then we have the meter squared, okay guys, and then times the concentration kilogram per meter, okay, then divided by meter, okay. Now it's gonna be cancels out, cancels out, cancels out, cancels out. Okay, so it's gonna be kilogram meter squared per second. Kilogram meter squared second, guys. This is the unit of our diffusion rate. And there's a second in the denominator. Okay? So 2.89 times 10 to the negative 6. Muna na siya mga to. Diffusion rate. We answered now the question letter A, which is calculate the diffusion rate. And only let's go to B. Okay. How many kilogram of oxygen will flow through this pipe in 15 minutes? Kaloka. And we have the unit of diffusion rate na kilogram per meter, right? You get the point? Here. Guys. So it's very easy to, to translate or to express already. So cancels. Okay. Ganun siya. Okay. So our unit will become cancel. Okay. M squared and cube. M habilin M. Wala siya. M squared talaga siya. Gi-review na ako guys. Kaya kasi kuan ka masayo. Charot! Kaloka. Diba? Okay, masayot niya ta. Okay, muna yung naitabo. Okay. Ay, wait guys. Wait guys ha. Muna siya no. So be careful talaga. Labi na maraming meter seconds. So ako siya yung review for the second time. Wait. I'm really confused why kilogram meter squared per second. This is the rate ng good siya. So my brain cells dictate me now, just now on the spot. Oh my gosh. Brain cells, he said, June, there's a square meter in the numerator. So there's an area. Okay, but you are only asking for the diffusion rate. So parang, oh, what's the connection of area there? Supposedly there will be no more area anymore, right? Because it is just like mass flow rate, volumetric flow rate, wala naman nga siya area sa numerator. So dali na kayo ni correct ang akong brain cells. So I have to review because I found it suspicious. Oh, ganon. If you found it suspicious, then you have to review for the second time. Okay, oh my gosh. So I do it again, the cancellation. Anyway, this is just only cancellation of units. Okay? So I have to show you. My gosh! Almost to na error. Okay, you have to be careful. The lessons here, you need to be careful in dealing with units and numbers. Okay? Muna siya na itabo. Okay. Wow, so it's special. Okay, so m squared over second. Let's investigate again, guys, meter squared. Okay. And then we have the density, right? Density over the length and distance of letter. Diba? Saya diba siya, guys? So m squared times m squared, m to the fourth. Now the m3 here, we cancel the m3 downward. What left in the numerator is the m only. So m and in the numerator n. So it's gonna be kilogram meter second, but we have still m in the denominator, then we need to cancel the m also. Oh my gosh, perfect. This is kilogram per second. Kilogram per second is literally means mass flow rate. Because kilogram is mass and the denominator is perfect. This is the correct unit. Sorry for my first attempt that there's still area in the numerator. I corrected just now. Okay? So mass flow rate will be equal to your diffusion rate. It's just the same. Since we are dealing with mass transfer, the term was exchanged only with diffusion, but actually that is literally mean mass flow rate. So we have now the mass flow rate of 2.89 times 10 to the negative 6 kilogram per second. Okay. Now in letter B, the question like this. Okay. How many kilograms of oxygen will flow through this pipe in 15 minutes? Okay, it's very easy because we have the time and our mass flow rate have also time in the denominator here. So we simply do the conversion factor. So it's gonna be like, what's that, 15 minutes? Convert the minutes first to second. How many seconds in 15 minutes? Okay, you need to convert elementary conversion. Okay, 15 minutes, 1 minute, 15 times 60. So it's gonna be 900. 1 minute, 60 seconds siya. So 900 seconds. So multiply this automatically with 900 seconds so that our mass will be in kilogram. Right? Okay, how many kilogram of oxygen man? So what will left in the unit is kilogram. So we compute already for the mass in letter B. So multiply directly with 900 seconds. So 9 seconds, sorry. 900 seconds. Okay, times 2.89 raised to the power negative 6 times 900. So we have 2.601 grams. This is already grams, guys, ha? Oh, kilogram pa rin siya, sorry, kilogram. Okay, sorry, because we use grams only in the derivation, but in the actual plugging of units, we use kilograms. I want to specify this. Okay, this is still kilogram. How many kilogram? It's also asked in kilogram also. Okay, so this is kilogram, not grams. The purpose for the grams only is to derive that how a density will be equal to concentration at certain condition. Okay, so this 2.601 times 10, what's that point? 10 to the negative 3 kilogram. Oh, so this is our kilogram or mass of oxygen. Letter B. So letter C, calculate the concentration gradient. It's very easy. Okay, we go back to the numerator here and there's our concentration gradient. So, agroy, 30 minus 10 na siya diretso. So 20. Okay, so 20 kilogram per cubic meter because we assume this as the same as concentration because of the condition. Okay, now if the condition doesn't meet this situation, do not also assume an ideal. Okay, so go back to the proper and original unit, especially if the problem has the original unit. Okay, this is only in this case. Okay, you got the point? So this is 20 kilogram per cubic meter directly without question, subtracting the 30 to 20. 30 to 20 ba siya? Or 30 to 10? Sorry. Wala akong memorize. Okay, 30 and 10. So this is 20. Letter D. What is the concentration of oxygen 2 meters away from the end of the pipe at higher concentration? So we have 30 and we have also 10. So the 30 normally from high concentration to lower concentration, because in theory and concepts, okay, the solids will pass, okay, or will move from higher concentration to lower concentration. That's why our 30 is in the inlet. Okay, and our 10 is in the outlet. So it really, jive. It's a really coincide to the theory. Now, if we sit at high concentration, see, from the end of the pipe at higher concentration, dito sa magsugod. Okay, not on the lower concentration sa 10. Now, we will illustrate. Okay, so drawing mo na to ang pipe na taas kaayos siya. Okay, charot, 10 meters. Okay, this is the pipe. Okay, 10 meters. And then, we have 30 concentration here at the inlet. We have 10 here. Okay, and we have 2 meters away from the, away from the end of the pipe. So 2 meters away from the pipe. So we need to try to measure from here to here, 2 meters away from 30. So, guys, this is not having formula, only analysis. Okay? So here from here is 2 meter. Okay, so this is 2 meter. Right? Here, 2 meter, from here 2 meter. Now, you will also illustrate another 2 meter. So if this is 2 meter away of the distance of this, so this will become also 28. Okay, why? I want you to explain why. This is the theory. Why? Because why you said Sir Sotero, if you put 2 meters away, the concentration also will, will decrease. Let's have the formula here. Okay, here in the formula. You can read that in the formula. The original formula is here, right? Okay. We have the length and we have the concentration. This is the mass transfer. If we take the proportionality, okay, let's do this by math again. Algebra. Okay, length is equal to the diffusion rate GAZ, or the mass flux, okay, times the diffusion coefficient of oxygen times area times the concentration gradient over delta C. Okay. Now, what do you notice in this equation? Okay, I say that 2 meters away from the high concentration, okay, what is the concentration? Okay, since here, guys, the length is inversely proportional to the diffusion rate. Okay, you get the point? See, inversely proportional. So therefore, if we keep on having 2 meters, another 2 meters, another 2 meters, another 2 meters, our concentration will increase. You get the point? Our concentration will increase, okay, if we keep on decreasing the distance, something like that. You get the point? Our diffusion rate. Okay, diffusion rate is inversely proportional with the length. Okay, and the length is directly proportional to the concentration. So if we keep on, this is becoming 28 now. 28. Okay, so bingo, 28 na yun siya. Because 30 will decrease to 2. Kaya wala siya formula, analyze lang siya. Okay? So dili kasagaran ba sa mga students, including me. Okay? Because hina man kog analysis. Okay? So 30, 28 na lang siya. So the answer will be 28 kg per cubic meter, letter D. You got the point? So another 2, decreasing of another length, 2 meter, until such time it will become to 10. So here, 28, another 2, 26, another 2, 24, another 2, 22, until such time it will become 10 here, the outlet, your concentration. So your concentration will decrease, okay? Will decrease, your concentration will decrease, okay? You got the point? Your concentration will decrease, okay? If your the length is very low. Okay? If your length is very low, the concentration will also decrease. Kaya ang diffusion rate man ang inversely. Okay? So meaning to say, if I have the mass flow rate na ako na-compute ganina na 2.8 something, so it will become less also somewhere along the way when you extend the distance to 10 concentration there in the last. So but here, the relationship is the length and the concentration man siya, directly proportional. So if we have a less length, okay, then our concentration also will become lesser as it goes to the outlet. This is very clear, right? Because of this formula. Okay? So letter E, this is 28 kilogram per kilo. How long will it take 100 grams of oxygen to travel through the pipe? Nakakaluka. Okay, so it looks like difficult, but it's very easy. Letter E looks like difficult, but it's very easy. All you have to do is to convert 100 grams to kilogram first, because our mass flow rate or our diffusion rate in terms of kilogram per second, and then do the conversion. It's gonna be, take note, we have here, diretso man siya guys. If we have 2.8 something, okay, 2.89 times 10 to the negative 6 kilogram per second, right? Okay. 2.89 kilogram per second mass flow rate or the diffusion rate, this one. So it's gonna be, then we have 100 grams, 1,000 grams, so 0.100 kilogram. Let's check with the calculator. 100 divided by 1,000. Okay, this is, yes, 0.1. Okay, 0.1. But take note guys, this you cannot multiply because the unit will not be cancelled. You will be dividing this one. Okay, since we have this one, okay, how can we do this? You have the mass flow rate. Okay, so what's the definition sa mass flow rate? What's the definition sa mass flow rate? Mass flow rate will be the density, density times area, okay, then over the time, right? So we will show by units so that it could be easily, cancelled. Because I forgot also, then the mass flow rate will be equal to, velocity, okay, velocity times area over the time, and then the mass flow rate will become, density times area times velocity over the time. Okay, right? So, mag-cancel na ka, then you can troubleshoot which is the mass flow rate and which is the volumetric flow rate through the units. We will do the units, okay? Because I did not memorize the exact, though I know, but let's check and confirm. Okay, density times area times velocity over time. So this is kilogram, cubic meter, meter squared, velocity, meter per second. Cancel. Saying cancel. So this is mass flow rate siya. Mass flow rate, density times area times volume over time. So the volumetric flow rate is only the area times velocity times time without the density. Okay? If we will get the other one holds through because it's just only two, mass flow rate and volumetric flow rate. It's very unusual to discover the pressure rate, the density rate. Actually, there are, but it's not unusual or rare. It's always mass flow rate, volumetric flow rate. But we don't also expect the unexpected, right? Density rate, pressure rate, like the temperature rate. We don't know, right? But the most common and popular all over the world is the mass flow rate and the volumetric flow rate. Okay? I'm not telling you that it will not come out, but I'm talking to you, these are widely used. Okay. Ganon. So if we have this, so we have the 100 grams. So we will start with the 100 grams, conversion factor, our basis of calculation. Okay. 100 grams. Okay, then 1,000 grams. Okay, is equals to 1 kilogram. Then 0.89 times 10 to the negative 6 kilogram second. Diba, i-divide ni mo because it will not be cancelled. Okay, something like that. So, ma-cancel na siya. 100 grams divided by 1,000 grams times 1 over 2.89 times the negative 6 cancels, what will left is second. Okay, do the basic math. Okay, 1000. Okay, times 2.89 exponential negative 6 over 9. So 2.89 negative 3. Wait guys. Negative 3, and then we have 100 grams. So divide on 100 grams. So 100. Okay, 100 divided by 2.89 exponent to the 3 negative is equal to 34,602 seconds. This is our time. Let's see how long will it take for a 100 grams of oxygen to travel through the pipe. Our answer will be 34,602 seconds. In the question, the time specifically is not mentioned. Now, if this is a multiple choice, then convert what is being asked, whether it is in second, okay, minute, hour, day, year, decade, or century. Okay? Again, second, minute, hour, day, week, month, decade, century. Okay? So that's the point of rate, R-A-T-E, time interval period. Okay? So it's gonna be 34,602 seconds. We don't have to convert because the required doesn't have units here. Okay, so any units will do. Yeah, right? So this is 34,602. Okay, we solved everything. Woo! Bingo! Okay, now this is Chemical Engineering Board Examination, November 1988. Okay, like that. So thank you so much guys for watching this lengthy live streaming. It took me 1 hour and 26 minutes to do this live streaming. Then you can comment down below in the comment section. If you are not subscribing yet my YT channel, then you can. You have the full freedom to do it. Okay, and then you can also click notification bell for some newest updates of I Am a Singer, Eternal Voice, OSH Engineer, Licensed Chemical Engineer. Thank you so much. Bye bye everybody. God bless.